Assalamu alaikum, dear students. I hope that you people are feeling well. In today's class, we are going to discuss the advantages of dimensional analysis. This topic is one of the most important topic of chapter number 1, that is measurement. So, in our previous class, we discussed about dimensions. We discussed some important dimensions of physical quantities, fundamental quantities as well as derived quantities. But in today's class, we are going to discuss some advantages of dimensional analysis. So, there are basically two advantages of dimensional analysis. First one is dimensional analysis helps us to check the correctness of any physical equation. So, it is basically used for checking the correctness of any physical equation. For example, if we talk about the very simple equation F is equals to ma, so in order to check the correctness of this equation, we take help of dimensional analysis. Basically, this dimensional analysis help us to check any physical equation, whether it is correct or wrong. And the second advantage of dimensional analysis is to derive a possible formula. Deriving possible formula. This is one of the most important advantage of dimensional analysis. But in our previous class, we are done with checking the correctness of any physical equation. Some of the students were having a problem with deriving possible formulas. So in this lecture, I want to discuss assignment 1.7. The students were facing some problems related to this, but in this class, inshallah, I hope that once you will watch this video, you will understand the concept of how to derive any formula for any physical quantity. So this is assignment 1.7. Let me show on the screen assignment 1.7, and this is very important assignment. Why? Because in the exercise we don't have such kind of numerical. So the assignment is find an expression for the time period t of a simple pendulum. The time period t may depend upon mass m of the bob of the pendulum, length L of the pendulum, acceleration due to gravity G at the place where the pendulum is suspended. So, after reading the assignment, according to the given statement, time period of the pendulum may depends on mass of the bob. It may depend on mass of the bob. And it may depends on length of the bob of the pendulum, and the time period of the simple pendulum may depend on gravitational acceleration g. So now let me write the power of these m power alpha, L power beta, and G power gamma. Why I am writing these powers? Because we are not sure. According to the given statement, maybe the time period of the pendulum is not depending on the mass. Maybe the time period of the simple pendulum is inversely proportional to length. Maybe time period of the simple pendulum is directly proportional to g. So suppose that we don't know about the relation of time period with these three physical quantities. Basically what we are going to derive the formula for the time period of a simple pendulum, that is t is equals to 2 pi under root L over G. With the help of dimensional analysis, we will find the relation this. Okay? So let me write these three. T is directly proportional to m power alpha, L power beta, and G power gamma. Why I am writing m power alpha, L power beta, G power gamma? The reason is that we don't, according to the statement, we are not sure how T relates M, L, and G. Either they have direct relation or inverse relation, or maybe time period will not be having any relation among these three quantities. Okay, so for that we are writing alpha, beta, and gamma. So now this is proportionality sign. When we are going to replace this proportionality sign, we put equality sign along with a constant. Suppose k is the constant here. So m power alpha, L power beta, and G power gamma. After this, we will take dimensions on both sides. So taking dimensions dimensions on both sides. Now this is t. T is basically time period. So time period is a kind of time. Time period is a time basically to complete one vibration. So it means that the dimension of this t will be capital T, because it is a kind of time. Whenever there is any time, so its dimension will be denoted by capital T within square brackets, is equals to k. And as we know that k is what? K is constant, so k is not having any dimension. K is dimensional less constant, and dimensional less constant do not have any dimension. So we will skip this k. And then we have m. The dimension of m is denoted by capital M within square bracket power alpha. Then we have length. The dimension of length is denoted by capital L whole power beta. And then there is gravitational acceleration, which is a kind of acceleration, and the dimension for the acceleration is Lt power minus 2 whole power gamma. I hope that till now there will be no any problem. So let's move for the next step. T is equals to m power alpha. I can write these all in one bracket. So L power beta and L power gamma, T power minus 2 gamma. Base is same, power will be added. So finally we get m power alpha, L power beta plus gamma, and T power minus 2 gamma. So now on the left side, if we see, the dimension is only t, and we know that its power is 1. But on the right side we are having m, L as well t. So I can write the dimension on the left side. It can be written like m power 0, L power 0, t power 1 minus 1, sorry, plus 1, is equals to m power alpha, L power beta plus gamma, and t power minus 2 gamma. So now by equating, we are actually going to find the values of alpha, beta, and gamma, so that I can put in this equation in order to find the formula for the time period of a simple pendulum. So by equating the powers of same dimensions. So for m for m for m now if we see here, the power of m is 0 and the power of this m is alpha. So this means that alpha will be equals to 0. Now by equating the powers of t, for t we have 1 is equals to minus 2 gamma. So gamma will be equals to minus 1 by 2. And now we can easily find the value of beta just by equating the powers of L, which is 0 is equals to beta plus gamma. And or we can also write this like beta plus gamma is equals to 0. We know the value of gamma, which is minus half, is equals to 0. So beta will be equals to 1 over 2. So now see, by putting the values of alpha, beta and gamma in equation number 1, what was our equation 1? That is t is equals to k m power alpha, l power beta and g power gamma. So t will be equals to k into m power alpha. We know that the value of alpha is 0 and the value of beta is 1 over 2 and the value of g is minus 1 over 2. So m power 0, which is equals to 1. So k l power half divided by g power half. Why? Because the power of the g is minus 1 over 2. So by shifting it into the denominator, its power will be positive. I can write this t is equals to k l by g whole power 1 over 2. And we know that 1 over 2 can be replaced by under root, so whole under root l by g. Now, this is not actually the formula for the simple pendulum because we don't have the value of k. So there are some limitations for dimensional analysis. Through dimensional analysis, we can derive any possible formula, but dimensional analysis do not give us information about this constant, this proportionality constant. But experimentally, the value of this k is 2 pi. So the experimental value of k is 2 pi. By putting k is equals to 2 pi, we will finally get t is equals to 2 pi whole under root l by g, which is the formula for calculating the time period of simple pendulum. So this is actually the limitation of dimensional analysis, or we can say that this is the drawback of dimensional analysis, which do not give us complete information about proportionality constant. So I hope that you people have got the concept of dimensional analysis and how to derive any possible formula. The procedure will remain same. So thank you students, take care and Allah Hafiz.